In this video, we're going to learn about liquids. Now, comparing liquids and gases, gases we assume have no intermolecular forces. Well, liquids do. And those intermolecular forces can help us understand the properties that liquids have as being quite different from those of gases. So for example, while gases have very low density and can be compressed as a result, liquids tend to be very dense, and as a result of the particles being close together, there really isn't much room to compress them. And why is it that they have this high density? Why is it that liquids are packed together very closely? It's due to their IMFs, their intermolecular forces. Because liquids are attracted to one another, because the molecules are attracted to one another, they stick together, and they have, as a result, a high density, and you can't compress them. Additionally, it is true that liquids will be able to diffuse. However, they diffuse very slowly relative to gases. A smell that you smell will go away pretty fast as it spreads very rapidly and diffuses into a low concentration. But in the case of, say, if we dropped a drop of food coloring into water, without stirring it, it would take quite a while for the food coloring to spread out. Diffusion happens slowly in liquids because it's not easy for whatever is diffusing to spread out, as it has to kind of push its way through a tightly packed crowd of molecules, of liquid molecules that are sticking together, and it's very difficult to push through. The next property that's one of liquids that's very noteworthy is the surface tension. And surface tension is what allows a water skimmer to walk on water. Water may not seem to be very sticky, but it actually is. It sticks to more water. And because there's this tension, because the water molecules stick together, the water skimmer can be supported by the surface of water. So the stronger the intermolecular forces, the greater the surface tension. And the stronger the intermolecular forces, the harder it is for molecules to push through and diffuse in a liquid. That's why, for example, well, we'll get to, there's also viscosity, right? Viscosity is related to diffusion. If you try to put a drop of food coloring and have that diffuse through, say, honey or molasses, which are very viscous due to the strong intermolecular forces in these substances, diffusion will happen even slower in that case. So also there is capillary action. And capillary action is the ability for a liquid to climb up something that it gets wet. So in biology, you may have done a lab that involved paper chromatography, where there was a dot of something from a leaf, for example, that was placed on a piece of paper, and that paper was put into a beaker containing water, and the water actually climbed up the paper. That's called capillary action, and that has to do with the intermolecular interactions between the liquid, the water, and the paper. Because water and paper are both polar, they have an affinity for each other. Water can almost defy gravity by climbing up the paper. But it's the IMFs that matter here. A nonpolar substance would not move so quickly. So next we have evaporation and boiling, and freezing point. So if a substance, if a liquid has a very high boiling point, that is explained by it having very strong intermolecular forces. If the molecules are held together with very strong forces and they're vibrating and they're moving around, well, if they're still attracted to each other, it's hard to get them to break away into the gaseous phase. And so you'll have a high boiling point. You'll need a very high temperature to cause the molecules to separate from one another. And with freezing, depending on the interactions with each other, if like water, for example, has a relatively high freezing, or sorry, a relatively, yes, high freezing point, if you cool it down and there are strong intermolecular forces, they'll really want to stick together before you get super, super slow moving molecules. So those are the properties of liquids, I should say, and how they relate to intermolecular forces. I hope this video has been helpful. Let me know if you have any comments or feedback in the comment section below. Thank you.